Hello, so continuing on this Leetcode contest 169, I'm going to try to solve the last problem. So let's put a timer up, maybe like a, what is it called, stopwatch, yeah. So let's say 40 minutes seems reasonable, 40 minutes, okay. So let's see what the problem says. So the problem says, given an equation represented by words on left side and the result on the right side, you need to check if the equation is solvable under the following rules. So it's an equation, kind of. So, given an equation represented by words on left side and result on the right side, words on left side, result on right side, you need to check if the equation is solvable under the following rules. Each character is decoded as one digit, 0 to 9. Every pair of different characters, they must map to different digits, right? And what else? Each word's I and result are decoded as one number without leading zeros, and sum of numbers on left side will equal to the number on the right side. Are decoded as one number without leading zeros. Okay, I think I need to decipher this a little bit more. So we have words on the left side, right? Some kind of left side of an equation, and then we have result on right side, right? And you need to check if the equation is solvable. Check equation solvable. That's what we want to do. Every character is decoded. So character decoded as 0 to 9. Every pair of different characters must map to different digits. So pair of C1, C2 maps to different digits. Okay. Words I. So these are like the criteria, rules. So these are the rules. And then we have words I, essentially. Each word and words I and result are decoded as one number without leading zero. Each words I and result, so gives you one number with no leading zeros. Okay. Sum of numbers on left side, so sum of numbers on left is equal to some numbers on right. Okay. To prove the equation is solvable, so true, return, we want a true, solvable, else false, right? Okay. So let's take an example. So the first example here, we have these words, right? We have, so example 1, we have words like that, and result is money, and words is send more money, kind of. And so you could essentially, so they are saying you could do this mapping, S to 9, E to, and then you would get send plus more would be actually equal to, well, I guess 9. Send is 9, E is 5, N is 6, D is 7, plus more where you have 1, 0, 8, 2. But what is this? So is this just a random mapping we come up with? Or, and for more money, it is actually M, which is 1, O, which is 0, N, which is 6, E, which is 5, Y, which is 2. And if we do this, so this is equal to the same, almost the same, but not really. 9, 5, 6, 7, 0, 8. Actually, E is not 2, E is 5. So my calculation there is wrong, because this here is actually this. So it is equal, so true. So essentially, I think I know what they mean here. So basically, if we can find a mapping that gives us numbers that are equal, then that means it's solvable. I think that's what it is. So if I look at the second example to make sure that my assumption here is true, so you have, so this is words, and this is the result. So if we do this mapping here, we would get, well, 6. So do we have to use all the words? That's a good question, I think. So do we have to use all words? So 6 is 6, I is 5, x is 0, 7 is 6, e which is 8, v which is 7, e which is 8, n which is 2. And that would mean 6 plus 7 plus 7 would be this here, plus 7, which is this, 2 times, right? 1 time and then 2 times, right? And then the result, which is 20, that's just equal to, so if we do this, you get, maybe I shouldn't be counting them like this. That would make me lose a lot of time. So what is T? 1, W is 3. Okay, I think I kind of have an insight. 8 is E, N is 2, T is, so basically you need to do a mapping for both, such as both numbers are equal without having a mismatch, I guess. So 1, 3, 8. So T is 1, W is 3, E is 8, N is 2, and T again is 1, and Y is 4. So you return true. Okay, so I guess okay. So we know that the word's length is less than or equal to 5, right? And we only have uppercase English letters. Okay, so only uppercase. Good to know. Okay, so number of different characters is at most 10, which means we won't have a case where we, because so it's 0 or to 9 would be enough to map everything, right? Okay, so how can I yeah, I don't know where to start actually, so let me maybe backtracking. So try all possible basically choices. So with backtracking, I know at least what I need to do, right? So I think with backtracking, I can say, okay, what are the when partial solution is a solution, and then candidates, I will see pruning later, candidates at each moment. And so So definitely if we have some kind of a helper that is trying to do that, we would have mapping, right? And we would have maybe I or something like that. But I would represent maybe I to represent position in words that haven't been used yet or something. And so maybe have something called digits left, right? So I would have a constraint on the candidates where must use digits left. So start with try all remaining digits essentially. So try all assignment essentially of the digits. So that would mean here so maybe have this is the word and this is the index of position in the current word, and so that's I, and then have K current word position. So if I is equal to the, so first, if I is equal to the length of the current word, which means just words K, then I could just return helper on K plus 1, and I is 0, and the mapping is mapping, and digits left is digits left. But we need to also have sum so far. And if K is equal to length of words, I would need to just say bigger. I will need to return sum so far, whether that's equal to mapping of result. Let's call this maybe M, right? Using M. And another thing is if sum so far is, so maybe just here we need to have something like result maybe prune if somehow sum so far is bigger than that. Okay, and now exploring this, we would say, well, we try one of the digits, right? So we'd say helper on k I plus 1. Mapping would be, so we'd say m of the current words letter, which would be words ki, equal to d, right? And then we would need to remove that, so we'd say m delete this, right? And then here we would say I plus 1, the new mapping. Digits left would be, we need to remove that, right? So maybe, what if I had, let's say, digits left equal to 1, 2, 3, 4, 5, right? And I want to remove, so let's say d is equal to 5. So if I say digit left minus d, that won't work. If I say minus maybe digit left, remove d. So if I do digits left, that's only destructive. So I would say digits left that remove d, and then I would use that. And then here I would need to, so this is basically choose, this is and choose, right? And then here I would say add d, add it back, right? And for the sum so far, it would be plus d, and that's pretty much it. And at the end we'll need to return whether and we need to define that. So mapping of s and m, so res is equal starts out as 0, and then we'd say for, so actually it can just be return sum of m of c for c in s, I think. So would that work? So it said false for some reason. Okay, I think I need to put it to debug this. Yeah, we need to call it actually, so start with the first word, the first letter. M is empty, digits left is range from 0 to 9, right? So range from 0 to 10, and sum so far is 0. This will need to be append. So y was not in there, right? Yeah, so we need to okay, so the mapping here needs to be more than that. So okay, so maybe I will keep track of the missing letters, right? I need to pass definitely digits left. And so here actually I will need to say so for these letters we will need to see if with the digits left we can find some that construct those, right? So if res is bigger than word sum, then return false. If res is equal to word sum and missing is empty, we can return true, because that means we are done. Now, otherwise, we need to check if we can. So, remaining would be basically right, and then we need to find if just try all digits, right, for all the remaining, right? Was actually a harder problem, I think. Okay, so this doesn't look like it will work because of what I had here, you know, because of this portion here. I feel like I have to do them at the same time or something. because for example with this what I'm looking for is that 6 essentially plus 7 plus 7, this here to be equal to 20, like this. So that means that if you go from the end here, that means that n here should be equal to y, and n is like we can take 4 and give y 4, right? A similar thing for e, we can 8 8 16, so we can say here 4 16, that means 6 here and give 1, have 1. So e is 16, t we could give t maybe so 8 plus 8 is 16, right? So why didn't this? Oh, because there is the 6 that will give you. Okay, that's so there is. You need to handle also carries, which kind of messes things up. Okay. Let me just try to get a hint here. Okay, that seems to be not a real solution. Okay, let me try this one and see if I can decipher it essentially. Also, yeah, I think this isn't necessary anymore because I couldn't. So if the length of the word is bigger than 1, we add it to start. So these are the first words. We start with the first letter. Okay, is that correct? So if I print start set equal to, so according to this, it should be equal to just SMM, right? SMM. It's a set, so just SM, and because this is the same, so we know those, okay? So we take the max length. So because we are kind of adding in a way like this, we take the max length. And if the length of result is less than any of them, that means we can't make it up, right? Because the number would be too big. Okay, so far so good. And then we have this DFS that starts like this with the first index, which seems like the index in the word, and I is the first position like I thought, and then the carry, the visited, and the mapping. And the mapping, okay? So if index is equal to n, we check if the carry is equal to 0. Why? So n is the maximum length for word, and index, I guess, is the okay, I'm just going to do this W here. Y minus index minus 1. If this is not the last word and the index, so basically I is so I would be the index of the current word, and the index is so we go to the next word if the index so exhausted current word, so go to the next. I did that in my previous solution, I think. We did this a lot, words plus result. So what is this? I'm not sure what this section does. So this is kind of choosing. So here I think I should prefer this to be D, and this portion here is choose, this portion here is unchoose. When do we do index plus 1 though? The next character, we do it here. If we reach at the end of the current word. But this minus index minus 1 is kind of disturbing. Okay, so this is their way of saying digits so that we can know the digits that are left, right? Oh, I think I know. This is just, I think this is just a way to do the indexing from the back. We want to start from the back, I think. That's why. I think that's why. Yeah, from low digit position to high digit position. So here we are doing the mapping for the word, for every word, for that index, and adding the carry and getting the sum and checking if that is valid, right? I think this is kind of the pruning section. So if it's equal to the results mapping sum modulo 10, what happens if result doesn't have a mapping yet? Or maybe it must have a mapping. So we have the carry and we check if it's equal, modulo is equal. That means it's valid, we can continue. And we go to the next character and try to get it for all of them. If we can't, then we are done. So that's kind of a way to prune this solution, to prune this. Okay, I think I understand this portion. And I understand this portion too. This is going to the next word. If it's already in mapping, otherwise we need to find a mapping for it. Okay, let's see, maybe contest people have better solutions. Nope, it's not simpler. Okay, let's maybe see if this would be easier to get going. So we go column to left by column and top to down by row. Our objective is, for when written arithmetically, when we see a character, we add a sign to a digit if it's an assigned. Otherwise, we use that digit. We also keep track of the sum, which is balanced at the end of a column. If the sum isn't divisible by 10, then the task is impossible. Otherwise, the digit carried is balance divided by 10. Why, when if it says indivisible by 10, that the task is impossible? I don't get it. Okay, let's see. So number of rows is the number of words. That's fair. We just append it to the number of words. The columns is the number of the longest word. Okay. The map of the assigned mapping. Assigned what is this? I don't know what that is. So search starts with column 0, row 0, and balance 0. And we check the stop conditions. So if the columns are bigger than we are done, we check if the balance. What is balance again? We keep track of the sum. So the sum we have so far. If we are at the last row, so we check if the balance modulo 10 is 0. Because we want this here to be true. And so I guess that the balance is the difference between the sum so far and the result. So we go to the next column. If this column is valid, we go to the next column. And this is the carry essentially. Okay. And then we get the word at the current row. Check if the column, if that word is done. So check if the column is bigger or equal to that word, which means that word is done. We need to go to the next word or the next row. With the current balance though. Yep, because the current balance means the number that is left. To get row minus column, I think that I get that. Okay. This is, we get the letter, so we are going from the right side, and so this is kind of equal to n minus column. And sign is 1 if it's one of the words, otherwise it's -1 for the result row, right? And now if letter is in the assigned, we just use that. We just use it. So that would mean we are still on the same column, but we are going to the next row. With balance is the digit, and depending on whether the last row is the result or not, we assign the sign. Okay, that makes sense. I think this is far better, more organized also. And then we go, if it's not assigned, we try to find an assignment for it. And so to do that, we go through all that's the index and the, what is this actually? Why is it AD here? If it's none, that means it hasn't been yet assigned. So this helps us know the assigned or the not assigned digits, right? So this is the digit because it starts from 0, right? So if it hasn't yet been assigned and either it's not 0 or it's the first word but the column is not the last, because the first of the last column, okay, the first letter of the last column, the first, so the column is not the last one, it's not the first one, right? Why though? But at least we know that this portion here is choose, okay, and this is in choose. So same thing, we remove the assignment as I did, and we re-add the digit to be available. So basically this is mapping, and this here is columns. So digits, so this is letter to digit. Try the next one, and the balance is the same thing, digit here. Okay, I think I understand it all except this portion here. Okay, I think I'm going to go with that one because So basically either D, which means it's not equal to 0, or if it's equal to 0, we check if it's the first word, we check if it's not the last letter of the first word. No, so if digit is 0, oh, because there are no leading zeros, I think that's why. Yeah, are decoded as one number without leading zeros. So okay, cool. Yeah. Okay, let's continue here. So okay, I think so. The main insight is to do it is that we are going to do something like this. So if you look at the example that we had, it's going to be 6, 7, 7, and we are going to try to see if adding those up like this will give us 20. With any kind of mapping, and so we would have rows and columns here. That's why we are starting with 0, 0 and a balance of 0. Our goal is for the balance to always be 0 because we want result to be equal to basically the sum of letters, and the way we are achieving that is using this sign. So we either add to the sum or subtract using that sign, and we just add result to the words. And we need a mapping that keeps track of which letter maps to which digit, and we need a mapping to identify which digits maps to which letter, so that we can know what digits can we still use that haven't been used yet. And we call search for the first column in the first row. And so columns basically is just the length of the maximum word, right, including the result, right? And because we want to process all of them, and we check if column is bigger than the current column, that means we are done. So this number of columns, so we are done. At that point, we just check if the balance we have so far is 0, because at every point we don't pass to the next column until we make sure the balance is 0, or there is a carry and the balance first digit is 0, or lowest digit or the digit is 0. And we check if this is the last row here, which basically means result column, result row. And at that point we need to go to the next column, right? Because we are done. To go to the next column, we make sure that we have 0 there, because the difference has to be 0. So basically, instead of doing this, we are going to go from this to something like this, plus minus, right, minus 20, and we want to end up with zeros. That's essentially what we are doing. And so we pass the carry here, and we go to the next column with the first row again, right? The next column with the first row. Now we take the current word and we check that the column is not, if it's bigger than the length of the word, the current word, that means we need to go to the next word, so the next row. Otherwise, we need to get the current letter, have calculate the sign, which is -1 for the result and 1 for the rest. We have two cases now: either there is a digit assignment or there isn't. If there is a digit assignment, we use it. A letter assignment, we use it, because we are going to use it so that, and then we will go to the next row, right? And so it's column, row plus 1, and for the balance we need to add the number corresponding to the current letter, and so that will be sign multiplied by letter to digits of letter plus the current balance. And right, because the current balance at the current row. And if not, we try all digits that are still left, and we make sure that we don't use any leading zeros, and then we choose a letter and go and try it. So we choose a letter among these letters that have so we choose a digit among these digits that have not yet been used, and we assign it and mark the digit as used by setting the letter that it's used with. And we search in the next row for the same column again. Again, we pass in the current balance, which is the balance plus the sign multiplied by the digit. and if that gets us true, return true, otherwise we unchoose and we continue trying the next digit. Okay. Okay, so I want to be able to solve it without having that that thing there. So maybe I could just go back to my okay, so it returns true. So I'm guessing it's because we need to do this here. And letter to digit for letter is not 0, or the column is different than the length. So letter to digit here we assign, and then we remove, right? So okay, so that passes without the call. Okay, so that's it for this live coding for this problem. Thanks for watching and see you next time. Bye.